Hi, so this is a problem about kinematics and vectors. I'll leave you the time for reading the different tasks. First of all, for a problem like this, it's very important to highlight in the problem what we know. We know that at time t is 0, the insect is at point A, and this point has a coordinate 0, 0, 6. So we're going to write it down. A equals 0, 0, 6. 2 seconds later, so t equals 2 seconds, the insect is at point B with these coordinates. So B is 6 minus 2, 6. And if we want, we can write down when this happens. So t equals 0 and t equal 2. Now, for solving task A, which asks find the vector AB, it's enough to write down the segment, oriented segment, which is a vector AB, as B minus A. So we're going to just write down B, 6 minus 2, 6 minus A, 0, 0, 6. And this is going to give us 6 minus 0, 6 minus 2 minus 0, minus 2, 6 minus 6, 0. This is AB. Point B. Show that the position vector of the insect at time t is given by this equation. Now, show that, it means that we have to show somehow mathematically that we have some ideas why this is the equation. Now, you can motivate writing a little bit that, first of all, you know where the insect is at time t equals 0. You know that the insect is in fact in point A. This one will become your position vector, which means this vector, which means the vector that you write as position vector in a vector equation of a line, which normally it's indicated like this, x, y, and z equal the position vector, let's call it small a with a vector, plus a parameter, for example here it's the time, times the direction vector that here we can indicate as v. I indicated with v because the direction vector is in reality the velocity. What is the velocity in reality? The velocity is the distance divided by a time in general. So it's how much meters you're covering in a certain amount of time. But in particular here, since velocity will be expressed in meter per second, it's how many meters you cover in a second. Now, v could be very well the vector AB, okay, 6 minus 2, 0. But in this case, the speed is describing something that is happening in 2 seconds. So in order for it to be the speed, meaning the amount of meter in 1 second, we have to divide this by 2. So the velocity in this case is just going to be 6 divided by 2, 3, minus 2 divided by 2, minus 1, and 0 divided by 2, 0. This is just going to be the velocity that we're going to insert in this equation. And A is just the position at t equals 0, which is the coordinate of A. So the line xyz is just going to be A coordinates, so 0, 0, 6, plus t times the speed we calculated over there, so 3 minus 1 and 0. Now, for point C, we have to write down the coordinates of the starting point of the bird. Now, here we have to underline starting position. What is the starting position? It's the position for t equals 0. It's when the time starts. So we go back to this equation and we plug in t equals 0, and we will get that the position is just going to be 36, 18, 0. Remaining part, in fact, will be 0. For point D, it's asking find the speed of the bird. Now, the speed of the bird is described by this direction vector. But there is a main difference between the velocity, which is the vector, and the speed, which is the magnitude of the velocity. So the magnitude of the velocity is just going to be square root of the components of the velocity squared. So minus 3 squared plus minus 4 squared plus 1 squared, which gives me 9 plus 16 plus 1, which gives me 26, which I could approximate if I have the GDC with 3 significant figures. Now we need to find task E. It says find the time the bird takes to reach the insect. Now here it means that somehow they want us to calculate the intersection point. How do we do for intersection in lines? Well, we equate the y component for one line and the y expression for the another line. And here we're going to do the same. So we're going to equate one line, 0, 0, 6, plus t, 3 minus 1, 0, to the other line, which is 36, 18, 0, plus t, and then we have minus 3, minus 4, and 1. What is special about this situation is that, as you can see, we have 3 equations, one for the x component, one for the y component, and one for the z component. But all the 3 equations, now I'm going to write them down, they contain t. For example, we're going to have 3 times t equal 36 minus 3 times t, minus t equal 18 minus 4 times t, 6 equal 0 plus t. So as you can see, this is a system of equations in one unknown. So it's clear from the last one that t has to be 6. Now we have to check whether this solution is valid for the first two. If it's not, it means that there is no intersection. If they all 3 agree, then it means that there is an intersection, and this is going to be at time 6 seconds. Now let's check the first one. The first one, if t is equal to 6, let's try to see what happens. So we have 18 equal 36 minus 18. So this one gives 36 equal to 36, which is true. What about the second one? We have a minus 6 equal 18 minus 4 times 6, which is 24, which gives me this part, minus 6. And here again, we agree with the left-hand side. So this one is verified. So it means that point E, we can answer it with a time of 6 seconds. Now let's find point F. Find the coordinates of C. It means basically find the coordinates of the bird or the insects at time equals 6 seconds. Now it means that we can use either one of the 2 equations. I'm going to choose the one of the bird. So F, I'm just going to write x, y, and z. That is just giving me the coordinates of point C. And I'm just going to insert times 6 seconds for t. In this way, what I get is a coordinate for x, a coordinate for y, and the coordinates for z for a time equals 6 seconds. So I'm going to have 36 minus 6 times 3, 18. I'm going to have 18 minus 6 times 4 here, and I'm going to get 0 plus 6 for the z component. So if I work out the arithmetics, right, 36 minus 18, it's giving me 18. 18 minus 24, it's giving me minus 6. And then I have 6 for the last one. So this is the coordinate of point C. I'll see you soon.